So these are the questions. The first question is, what is meant by the Newton first law of motion? So you need a statement for the first law. So what is the meaning of the first law? You will mention if there is no resultant force, the object will remain at rest or move with a constant speed. Or continue to move with a constant speed if resultant force is zero. Then Newton third law identifies the pair forces. State two ways in which the forces in pair are identical. Identical means how the forces can be same. So how the forces will be same? They will have the same magnitude, same type. It will be same magnitude. Magnitude means value. Same type of forces, same line of action, same time of action. State two ways in which the forces are different. So how the forces can be different from each other? They will act in opposite direction, act on different objects. In the next question, one of the forces acting on the car can be described as follows. The earth exerts a downward gravitational force of 12,000 Newton on the car. Describe the its Newton third law pair force. So earth gravitational force, like there's a car on the surface of the earth. So if this car experiences a 12,000 Newton gravitational force, so what will be the pair force? A pair force will be 12,000 Newton by the car on the earth in opposite direction. So the car exert upward force on earth equal to 12,000 Newton. So that's called a Newton pair force. So forces always act in pairs. In this question, the photograph shows a physics teacher carrying out a demonstration related to a vertical motion having two coins, coin A and coin B. Coin A is placed at the top of a smooth ruler. Another coin B is there, which is placed on the table. On the one hand is acting as a pivot. So this one is pivot. The other hand gives the ruler a sharp horizontal tap, means it will like move in this manner. So the coin A will fall vertically and coin B will come down. Coin A fall vertically, where coin B is pushed horizontally off the table. Both coins are heard to strike the floor at the same instant. Use Newton's first law, explain why coin A has no horizontal motion. Means why it does not move horizontally, it only move vertically. So we have to use a Newton first law. So according to Newton first law, because initially the object was at rest. So when it is at rest, there is no horizontal force. Vertical forces are there because as the coin is stable, if I make a side view of this cushion, so if this was a table and a ruler is there, a scale is there, and on this scale there is another coin is placed. So as you can see, for this coin A, vertical forces are, there is no horizontal force. The weight will act downward, the downward force is there, and the normal contact force that will be upward. So the vertical forces are there, there is no horizontal force. And the moment when we remove this, so the moment when we remove this scale or a ruler, so now there is no upward force because it's not in contact, so only the downward force is there. That's why it moves vertically, there is no horizontal motion. So answer for this, there is no, like initially the forces were vertical only. No horizontal forces. So initially forces are, there is no horizontal force, only vertical forces are there. And according to Newton first law, there, because according to Newton first law, if there is a resultant force, there is acceleration. But there is no resultant force in horizontal direction. So it does not accelerate or change its direction of the motion. Is it clear, this first one? Is it clear, the first part? Then for the second one, explain how this demonstration show independence of vertical and horizontal motion. So basically what happened, two coins, one was placed on the ruler, another coin was placed on the table. When you move the scale, one coin will have both horizontal and vertical motion, another one only vertical. But what they mention coin A fall vertically, B fall of horizontal push, but both coins strike at the same instant. So how demonstration show the independence of the vertical and horizontal motion means one of them is having only vertical, the other one is having vertical and horizontal. But the two motions are independent of each other, means the way they are moving is different, but still they hit the ground at the same time. So why they hit the ground at the same time? So this shows that both have the same acceleration. Same vertical acceleration. Otherwise, what happen if one of them, if they don't have the same vertical acceleration, they will not hit the ground at the same time. They will take different time, but it shows because they have the same vertical acceleration. So as they hit the ground at the same time, even coin B is having horizontal motion, which shows horizontal and vertical motion are independent of each other. Means does not depends on each other. Is it clear? As both of them hit the ground at the same time, so both have same vertical acceleration, even though the other one is having vertical acceleration as well as horizontal motion as well. During a lesson on Newton's law of motion, a student say, we do not really need to bother with Newton's first law because it is included in the second law. Means first law is included in the second law. State the first two laws of and explain how second law includes the first law. Look, how what are the statement if an object is at rest? First thing is for mentioning a statement of the law, writing the correct statement that if an object is at rest, it will remain at rest or object does not accelerate or if an object is moving, it will continue to move until unbalanced force act on it. And according to second law, when there's unbalanced force act on object, it will accelerate. So you can see the two laws are actually interrelated. If there is a resultant, the first law state the resultant force is zero, so object will not change the state. The second law state if there is a resultant force, the object will have acceleration. So when you mention for first law there is no acceleration or constant speed, if resultant force is zero. For second law, if there is a resultant force, the object will accelerate. So like both laws are interrelated. If there is a resultant force, there is acceleration. If there is no resultant force, there is no acceleration. Look, in this question, Einstein imagined a person in a large box without a window. Like a person is there inside a box and there's no window to see outside. He suggested with no way to see outside, the person could not tell whether they're experiencing a gravity of Earth. So the person could not tell whether they are experiencing the gravity of the Earth or they're in a deep space far away from any effect of a gravity and being accelerated at a rate of 9.8. Means the object are accelerating at a rate of 9.8. So one is accelerating in a deep space, another one is on Earth, stationary on Earth. Both are inside in a large box. Account for Einstein's suggestion by explaining in each case what a person standing in the box would feel through their feet. It may help to assume a person mass is m. So you can consider the mass of the person is m. Here also the mass of the person is m. So what happened for the first one, for a person who's on earth standing, so the weight of the person will act downward. If something is at rest, if something is not moving, means the resultant force should be zero. So for the first one, the person who's on earth, the resultant force is zero because he's not accelerating. But for a second person who's having acceleration of 9.8, so to have an acceleration, there should be a resultant force. So what happened for a person who's standing on earth? So his weight will act downward, and there will be a normal contact force upward, and the resultant force will be zero. Like example, if weight of the person is 600 Newton, upward force from the surface is also 600, but the resultant force on this person will be zero. But if the object is, if this whole box is accelerating, whenever objects are accelerating, like the whole system is accelerating, so acceleration of the system is same as acceleration of the object which is inside. Like if you are inside the car and your car is accelerating, it means acceleration of the car is same as acceleration of the bodies or the person inside. So if this whole box is accelerating, so the person also should have an acceleration, and it will also have the same acceleration. And if an object is accelerating, there should be a resultant force. So what happened? There will be a resultant force on this person, which causes acceleration. And how to find a resultant force? By using F is equals to m a, or resultant force. In this case, we can say mg. Why we can say mg? Because it is accelerating due to gravity, which is 9.8. Is it clear? The two conditions. So for the first one, weight is acting down, normal contact force from the surface is up. There is no resultant force because the person is not accelerating. But for a person who's moving through a space, there must be a resultant force because the box is accelerating. Acceleration of the box and acceleration of the person will be same. So he will experience the force which is equals to m a, or you can say m g. Is it clear, this concept of resultant force which cause the object to accelerate? Any doubt in this part? Another question related to Newton law. Opposite poles of the magnets attract one another. Using a principle, a student tried to design a toy car that could self-propel. Means self-propel means the car can push itself and move. His design is shown. A magnet A is attached to the body of the toy car, and a magnet B is suspended from the driver hand by a rigid rod. Magnets are identical. Magnet A is identical to magnet B. The student stated that as long as the opposite poles of a magnet are facing each other, the attractive force created should cause the car to move. Why in practice, like this could never work? Like in reality, this will never work. Students suggest, but this will not work. Why this will not work? Because what happened? There should be a resultant force on the car to move. As the two magnets are attracting each other, if no magnet A is attracting magnet B, a magnet B is also attracting magnet A. But what happened? You can see the magnet B is also is in hand. A person is holding. So if this was a force of 10 Newton, this is also a force of 10 Newton. So what it create? Because the two for Newton pair forces must act in pair. So action and reaction forces are equal and opposite direction. So there is a 10 Newton attraction force is there, but as a person is holding a magnet B, so there is a 10 Newton backward force. So on the car, there is no resultant force. If there is no resultant force on the car, so this car will not accelerate. So when you mention or write the answer, what you will mention, like according to Newton third law, a magnet A exert a force on magnet B and magnet B exert force on magnet A. Two forces are equal and opposite in direction, but there is no resultant force, because to get a acceleration or change in speed, there must be a resultant force. So if there is a force of magnet B on A, there's a force of magnet A on B, but what happens if this is 10 Newton force? This should also be 10, but the thing is this 10 Newton force is acting. If 10 Newton is there backward and 10 Newton is forward, so what it create, the resultant force will be zero. If resultant force is zero, the object will not accelerate, or it will have zero acceleration. Now in this question, a lorry gradually accelerated from rest, and there is a box of mass 200 kilogram on the back of the lorry. The forces are not, the box is not tied to the lorry. The lorry accelerate from rest to 15 meter per second over a distance of 39 meter. Calculate, show that acceleration is about 3. So how to calculate acceleration? We have this formula, 2as is equals to v square minus u square, or a is equals to v square minus u square divided by 2s. So v is the final speed, which is 15, u is the initial speed, which is 0, and divided by 2, and the distance 39. So when we'll calculate, we'll get approximately 3 meter per second square. So if acceleration of the truck or a lorry is 3 meter per second square, even though this box appeared to be stationary on the trolley, but in reality, it will also have the same acceleration because of the gravity, because of the motion. Otherwise, if the acceleration of the box is less, then the box will fall off from the ledge. If acceleration is higher, then the box will move in forward direction. But both have the same acceleration, so there is no resultant motion. The maximum frictional force between the lorry and the box is 630. So frictional force is there, which is 630 Newton. Explain why this limit the maximum acceleration that a lorry can have without box falling off. So how it limit the maximum acceleration? Because the maximum acceleration, what could be the maximum acceleration of the maximum frictional force between the lorry and the box? Means friction cannot exceed more than 630. If that's the maximum value. So if we calculate the acceleration, for this part, the maximum frictional force is 630 newtons. And we already calculated the acceleration, which is about 3. The acceleration of the lorry is same as acceleration of the box. The frictional force is 630 Newton maximum. The question is why it limits the maximum acceleration, means why a lorry cannot have acceleration more than that. So what we can use the formula F is equals to ma. If the force is 630, m is the mass, which is 200, acceleration, so 630 divided by 200. So when we calculate acceleration, it will come out 3.15. So this is the maximum acceleration which a lorry can have. It cannot have acceleration more than that. Because if F is equals to ma is there, if friction force cannot exceed more than 630, it means the acceleration of the lorry cannot exceed more than 3.15. And for the next part, if it is on inclined surface, whenever object is on inclined surface, we divide the weight into component. So weight is acting downward. So how we divide the weight into component? When we draw an axis, if we draw an axis, the angle which the surface is making with the inclined plane is same as the angle between the weight and the new axis. When we take axis on inclined, means if this angle is 30, this will also be 30. So the component of the weight which is with an angle, that will be known as W cos theta, and the component of the weight which is against the angle, that is W sin theta. So the component of the weight which is always with an angle is cos theta, and against the angle will be sine. So they are asking, state the expression for the component of a weight of a box parallel to the back of a lorry and perpendicular. So parallel, the component which is parallel, that's W sine theta. You can see parallel to the inclined surface, W sine theta, and perpendicular will be W cos theta. And the angle is increased until the box is just about to slide down. Given that the friction is 0.32 R, calculate the theta. So whenever objects are there on inclined surface, so this is W cos and the other one is W sine. So we can say R is equals to W cos theta, and we can say F is equals to W sine theta. And they mention F is equals to 0.32 R. So in place of F, I can write 0.32 R is equals to W sine theta. And what is R? R is equals to W cos theta. So in place of R, we can write W cos theta. So W cos theta, W sine theta. So W will cancel with W. So 0.32 is equals to sine theta over cos theta. And sine theta over cos theta is known as tangent theta. So 0.32 tan theta. And if you need theta, theta is equals to tan inverse 0.32. You'll get the theta. So basically what we did, the R, the perpendicular component to the surface, is equals to W cos theta, and F is equals to W sine theta. And we compare the two equations or substitution method. First, we substitute value of F is equals to 0.32 R, and R is equals to W cos theta. We substitute that and get the angle. Is it clear? This is in trigonometry, you use to find these angles using a trigonometric ratio. Is it clear, this part? Okay, so this is the today's class, the Newton laws of motion and the acceleration due to gravity without air resistance. There is with air resistance as well, that you already took in in O levels about the terminal velocity. So I'll end the session, share the weekly homework with you, and tomorrow I will discuss the last week homework. So submit your homeworks before the class. Any doubt related to the class today?